Good evening. Can you hear me? Okay. Okay. I so much good. Yeah, this one Karada. You met? I discussed this question. This is a rotational motion now. No. Okay. Let's discuss. Let's do this question. It's a very good question. Rotational motion. It is 2021 final question. Final question part B. Part A from electricity and yeah, only electricity and magnetism. Part B from rotational motion. Okay, read the question. A light string wrapped around a pulley is pulled with a constant vertical force of 30 Newton as shown in the diagram. As shown in the diagram. Right? It is a light string wrapped around a pulley is pulled with a constant vertical force of 30 Newton, right? With 30 Newton force given in the diagram. The moment of inertia of the pulley, that's moment of inertia, capital I think you remember, right? Moment of inertia, the reluctance to change the motion type. Moment of inertia of pulley around the axis of rotation is 2 into 10 to the power minus 2 kilograms square meter. Radius of pulley is 0.2 meter. The radius is given. This is a pulley. Assume the pulley start from rest and this start from rest. That's important. And string does not slipping. The string is does not slipping when we apply the force, right? Equations related to rotational motion listed below. Some part of equations given. Rho equal I alpha, rho equal FR equal. This is my torque equation. Both torque equations given, right? Both torque equations given. Abhinga violate. A signal problem. Okay, sorry. Give me a second. Okay, sorry. Okay, Vihanga, we doing 2021 essay question, physics question number 10, part B. A light string wrapped around a pulley is pulled with a constant vertical force of 30 Newton as shown in the figure, shown in the diagram. The moment of inertia of pulley around the x-axis rotation is given. Radius of the pulley is given 20 centimeter, that means 0.2 meters. Assume the pulley start from rest and the string does not slipping. Equations related to rotational motion are listed below. The first equation, rho equal I alpha, you already know. Rho equal I alpha mean the torque equation. The second one, second torque equation, rho equal FR. Third equation, rotational kinetic energy, half I omega square, rotational kinetic energy. I equal mr square. I equal mr mean moment of inertia equation. I mixture on just then theta equal omega into t, the moment may angular displacement, angular velocity equation, and two motion equations given. Two motion equations given. Hurry. Calculate the torque applied on the pulley. Okay, calculate the torque applied on the pulley. How to get the torque? Hurry, Hadam. How to get the torque? How to get the torque? Now we have two methods. We have two equations, rho equal I alpha and rho equal FR, but we don't know the alpha, but F and R is given. The applied force and radius given, then rho equal FR. This is part one answer. Then F is 30 Newton, radius 0.2 meters. 3 into 2, it is 6 Newton meter is the torque. 6 Newton meter is the torque. Right? Very simple. Make normally physics question don't afraid for diagrams, long paragraph. But questions very simple. Write an equation to show the relationship among torque, angular acceleration, and moment of inertia. The second one, answer the torque equal I alpha. Rho equal I alpha is the equation. Rho equal I alpha, it is already given. Rho equal I alpha. Calculate the angular acceleration of the pulley. Third one, calculate the angular acceleration of the pulley. Now, torque already know. What is the torque? 6 Newton meter. 6 Newton meter. The moment of inertia is given 2 into 10 to the power minus 2. 2 into 10 to the power minus 2 into alpha. then alpha equal 6 divided by 2 into 10 to the power minus 2 mean 0.02, right? Have we complete this question? Mikkarada? Yeah. That's why I asked you. Hari, come on, happy icon. Yeah, I can remember we discuss. Yeah. Hari, come on, then 6 divided by 0.02. What's the answer? Then you can answer, no? Quickly. 6 divided by 0.02. Quickly. Yeah, 6 divided by 0.02. That means 600 divided by 2, it is 300. RAD is minus 2. RAD is minus 2. 300 RAD is minus 2. Okay, angular acceleration done. It is 300, right? With me? Understood? Radians per square second. RAD is minus 2. RAD is minus 2. When the pulley has rotated 25 turns, 25 rotations, calculate the following. Angular displacement, 25 revolutions. You already know any object within one revolution, it is 360 degree. 360 degree means 25 radian. 25 radian, then 25 radian mean 25 turns mean 55 rad. 55 rad. Now 5 equal 3, then it is 150 rad. 150 rad. 150 rad. Simple things, right? The angular velocity, how to calculate angular velocity? Angular velocity. Yeah, we can use this equation because we don't know time, right? But we already know angular acceleration and angular displacement. I'm going to erase this part, talk calculation part. Okay, after that, let's do area volume question, mathematics question. Okay, we need a motion equation without time because we don't know time, right? I want to find final angular velocity, right? Omega squared equal omega naught squared plus 2 alpha theta is better. I need omega squared don't know. Omega naught squared start from rest. If it is starting from rest, it's 0. 2 into alpha, you already know, angular acceleration 300. Theta, now 25 revolutions, theta 150, right? 150 radian, right? Then omega squared equal 2 into 300 into 150. What is the value? 2 into 2 into 3, it is 6. 6 into 15. 15 into 6. 90, no? 1, 2, 3. 90,000. Omega equal 90,000 square root. What is the value? You meant. It's 90,000, right? 9,000 or 9,000? Yeah, 90,000. Then 90,000 square root 300. Then omega equal 300 radians per second. Omega equal 300 radians per second. I use the motion equation without time. I select this equation because it don't have time. That's I have given this whole motion equations in the tube. This is a one and only motion equation without time. Omega squared equal omega naught squared plus alpha 2 alpha theta. 2 alpha theta. Okay, then it is asking kinetic energy, angular velocity done. Kinetic energy equation also given half I omega squared. I omega squared, half is a constant, I is given, the moment of inertia given. 2 into 10 to the power minus 2. 2 into 10 to the power minus 2. Omega squared, omega 150 into 150. 150 into 150. Sorry, 300 into 300. Now omega squared 90,000. No? 300 squared. Then 2 to 2 cancel out. It's 900 joules. 90,000 into 10 to the power minus 2, 900 joule. 900 joule. Okay, giving reasons or showing steps, calculate the work done by the 30 Newton force in rotating the pulley through 25 turns. What is the answer? That one also 900 joules. That one also 900 joule because the work done is equal to, you have to mention the reason. You have to reason compulsory. Work done by pulley, work done by pulley equal to rotational kinetic energy in 25 turns. 25 turns. 25 turns. Okay. That question we already discussed. Let's say I rapidly complete. Okay, any doubt? That is the answer. Any doubt? Nabil? I complete rotational motion. Met me? You didn't this. Okay, no problem. Yeah, without completing this lesson, it is difficult. No problem. You can go to this lesson. Hi. Okay, let's go to area volume question. This one. Let's do this question. Make karada. Vihanga. It's 2018 question number 5. You met? So we discuss. Okay, let's do this one. This is a good question. We can revise again our equations again. The flow the flow plan of an equatorial hexagon shape. All fourth is shown in the figure 1. The center of the fourth is O. This is the center. And the side length is 60 meters. Side length 60 meters. The main entrance of the fort at the AB wall and shape of it is depicted in figure 2. Figure 2 given the main door. This is the shape. It's an arch shape. There are 6 similar towers in A, B, C, D, E and F corners and the shape of a tower is shown in the figure 3. There are 6 similar towers A, B, C, D, E, F. Yeah, 6 similar towers on each corner of the hexagon as shown in the figure 3. This type tower, right? This type tower. Consider phi equal 3.14, root 26 equal 5.01 and root 3 equal 1.73 in calculations. Right? And sine, cos, tan basic ratios given. Sine 30, cos 30, everything given. Using the data in the given figures, calculate the following. Length of FO. It is 2000. Clearly note down. Otherwise, same questions we can again repeat it. 2028 2028, not 28, 18. 2018, question number 5. Essay question number 5. Part A, first part. Using the data in the given figures, calculate the following. The length of FO. FO mean this point to this point. How to get this length? Now the hexagon side length is given. Hexagon side length is given 60 meters. 60 meters. Then what is the FO? Okay, calculate this and send what is the FO length? What's the FO? What's the FO? Vihanger? Other? Okay, each side 60 meter, right? 60 meter each side. Each side 60 meter. I want FO length. F to O. F to O. This point to this point. Anyone? Met me? Think. Yes, Dino. Okay, now what is the angle you met? What is this angle? Yeah, met me. Good. This angle, the total 360, then 360 divided into 6, then it is 6 degrees, right? Then total angle, the total angle of remain 120. Yes, 120. May this angle plus this remain two angles sum, it is 120. Now you can see opposite sides are equal. Each angle opposite sides are equal. This one and this one. Opposite side equal mean 120 divided by 2, it is 60. Then you can, if it is angle equal, it is equal to triangle. It is an equal to triangle. Then this one 60, FO also 60. Understood, Nabil? Yes. Since angles equal, all sides should be equal. Then first answer, FO equal 60 meters. The reason is not compulsory, but you can mention the reason equal to triangle. Equal to triangle, right? equal to triangle. F equals 60 meters. Okay, let's move into second one. The area of the base of the tower. The area of the base of tower. Then what is a tower? Tower එක කොහෙද තියෙන්නේ? This figure 3 given tower. බලන්න question. There are 6 similar towers. A, B, C, D, E, F corners of the shape of tower is given in the figure 3. The question asks the area of base of the tower. This is a base. This is a base. How about the shape? How about the shape? It's a circle. It's circle. It's a circle. It's a circle. What is the radius? Vihinga, what is the radius? 1 meter, yes. 1 meter radius circle, because diameter is given 2 meter, then radius equal 1 meter. Radius equal 1 meter. Radius equal 1 meter. Then area equal 5r squared. 5 value, now you can't use 22/7. Right? The 5 value is already given. 5 value equal 3.14. Then question එක දුන්නා නම් again you can't use another values. 3.14. Why it is? (3.14) R1 squared. Then 3.14 is a value. 3.14 square meters. 3.14 square meters. 3.14 square meters. 3.14 square meters. Right? Simple. Next one. The floor area of section ABCF. The floor area of section ABCF. ABCF. Okay, you have two options. You can get the triangle of one section, one triangle, and multiply by 3. Without that, what is this total part shape? What is this shape? ABCF. What is this shape? The මේකම ගත්තම you meant. What is this total shape? It's a trapezium. Very good, Nabi. It's a trapezium. It's a trapezium. Yes, it's a trapezium. Then what is the side of this? It is 60 meters. This side 60 meters. Then what is this slide? It's 120. 60 into 16. 120 meters. What's the perpendicular height? What's the perpendicular height? Okay, perpendicular height you have to calculate. Perpendicular height. H. Now it is 30 meters. And it is 60 meters. Then I can get the H. Now 60 squared equal 30 squared plus H squared. Right? 60 squared 3600 equal 900 plus H squared. 3600 minus 900. What's the value? 2700, no, equal h squared. H squared. Okay, now you can get the h. Give me a second. Okay, get the height. We have another method. We can use trigonometry, right? We can use trigonometry. We can use trigonometry also. Now it is 60. This angle 60. Now you can use sine. Sine 60 equal h over 60. Then sine 60 equal root 3 over 2 h over 60. Then it is 30. H equal 30 root 3. 30 root 3. Yes, 30 root 3 mean 51.56, no? Yeah. 51.96. Good. 30 root 3 dama. 30 root 3. Alright. Third one. The question asks trapezium area. Trapezium area. Trapezium mean ABCF area. ABCF area equal 120 plus 60. A plus B divided by 2 multiplied by perpendicular height. Perpendicular height 30 root 3. 30 root 3. Now how to get this? 120 plus 60, it is 180. 180 divided by 2, 90 into 30. The root 3 value is given. The root 3 value is given. Root 3 value එක දීලා තියෙනවා. Root 3 value is given 1.73. 1.73. අපි ඒක දාමු. 1.73. Then what is the area? 9 into 3 into 1.73. 4,671 square meter. Right? Understood? Nabil? Met me? Correct? Okay. Fourth one. Fourth one. The area of inner flow of the fort. The complete area of the fort. That means the complete area 2 times trapezium, right? ABCF 2 times equal to complete area. එහෙනම් අපි multiply by 2. Very easy. 4671 full area multiplied by 2. Get the full area. Okay, this is the full area. Right, Vihanga? Correct. Okay. Now, let's move into B part. The door of the main entrance is made of 0.3 meter thick woods. The door of the main entrance means figure 2. The figure 2 given the door, main door. 0.3 meter thickness, that means 30 centimeter thickness, right? The shape of the upper part of the door is semicircular as shown in the figure 2. It's a semicircular part. It's a semicircular part. Yeah, up to this level it is a rectangle. The above part is semicircle part. Okay. Now, calculate the area of front surface of the door. Calculate the area of front surface of the door. Okay. The full complete area equals same rectangle area plus semicircle area, right? Rectangle area plus B1 full area, full door area, rectangle area. What is the rectangle area? 2 into 5, it is 10. 10, that's the rectangle area. 10 plus semicircle area. 5 value is given, 5r squared over 2. Then 10 plus 5 means 3.14. It is given. It is given. The radius is squared. What is the radius? What is the radius? 1 meter, right? 1 squared. 1 squared again 1. Divide by 2. Then 10 square meter plus 3.14 divided by 2. What's the value? 3.14 divided by 2. 1.57. 1.57. 1.57 square meter. The answer 11.57 square meter. Understood? It's easy. $11.57 square meter. Dinul, correct? Behind you met Nabil? Okay. Okay, let's move into next one. The mass of the cube meter of wood is cube meter, not square meter. The mass of cube meter of wood is used to make the dough is 100 kilogram. Then calculate the mass of dough. Calculate the mass of entire dough. Then what's the method? First of all, you have to calculate the volume of dough. Then you can get how many cubic meters in the dough. Then 1 cubic meter equal to 100 kilogram. Then your volume you can multiply by 100. Okay, get this value. Get the volume of this dough. This is the dough. This is the shape of the dough. It is 30 centimeter or 0.3 meter thickness. 0.3 meter thickness. Then you can get the volume. It's a uniform cross section object, right? First get the volume, then multiply by 100. That's a kilogram. Okay, what is the mass? You met? What's the mass? Okay. First you can get the volume, no? Okay. How to get any uniform cross section object volume? Met me, I got? Okay, uniform cross section object volume, uniform cross section area. This is a cross section area multiplied by thickness or length, right? Thickness or length. Hi. Then this is the area of the dough, 11.57. Second one, the volume equal 11.57 multiplied by 0.3 meter. It is square meter. Then we can get the volume, cubic meter. 0.57 So 11.57 into 0.3. 3.471. 3.471 cubic meter. Yeah, this is the volume of the dough. Yes. Then the mass, but this question asking the mass of the dough, the question given 1 cubic meter equal 100 kilogram. Then it is this value multiplied by 3.471 cubic meter multiplied by 100 kilogram. Then you can get the mass of the dough. 347.1 kilogram. Yes. If the tower given in figure 3 consists of cylindrical part and the right circular cone. Yes. It contains cylindrical part and right circular cone. Calculate the surface area of the tower. Calculate the surface area of tower excluding the base. Without base. Without base, calculate the surface area of the tower. Okay. Now this is the part C, no? Part C. Hari, Hadam. This is the shape of tower. It is a cylindrical part. It's cylindrical part and right circular cone. Like this. Right circular cone. 1 meter radius and 10, 5. Radius 1 meter. 10 meter cylindrical height. 5 meter cone height. Cone perpendicular height, right? This is a cone height, 5 meter. Hari. The base is excluded, right? Don't need base. Don't need. Okay, tomorrow I hope to complete quantity of heat, second part of heat lesson. Where we stop heat lesson? Dinul. Where we did finally in heat lesson, we did latent heat. Latent heat. Thermal curves. Karada. A physical state change only. Oh. Oh. Then tomorrow we have large part. Tomorrow we're doing specific latent heat and latent heat, right? Then yeah. Tomorrow we have very important part. Then we are so late. Now in our physical class we completed up to, yeah, we did specific. Yeah. In physical class we completed latent heat only. Yeah, tomorrow I hope to complete the latent heat. Okay, what is the area? What's area? Okay, first you can get the curve surface of cylinder. Curve of cylinder. Curve surface of cylinder 25RH. I think you can remember. 25RH is the curve surface, outer surface of cylinder. 2 into 5 value is given 3.14, radius 1, height 10. 2 into 3.14, 6.28. 6.28 into 10, 62.8 square meter. Correct? Then curve surface of cone. What's the equation? Phi r, phi rl. Only phi rl, because no, the base is not open, right? It is a closed. Phi 3.14, radius 1 meter, but slant height is not given. Slant height is not given. It is 1 meter. 1 meter. You have to use trigonometry. Now L squared equal 5 squared plus 1 squared. L squared equal 5 squared 25, 1 squared 1. L squared equal, L equal 26 square root. How to get 26 square root now? Using calculator. Dinul, how we can find 26 square root? ගන්න විදියක් කිය. Humit. $26 square root. No, you can't use calculator. 26 square root already given. 26 square root already given. 5.01. කැල්ලකින් ගහුවත් මේකම තමයි නේද? 5.01. 5.01. Then 3.14 into 5.01. Use calculator. $15.7314. Then you can get the total area. Total area, set the value. Total area. Add cylinder curve surface area plus cone curve surface area. What's the value? Nabil? What's the value? Yeah, 78.5314. Yes, good. That's the total area. Okay, let's do final one. Obtain the tangent value of the angle of elevation to the top of the tower located at the position F as seen by a child at the position of O, whose eye level is 1 meter above the ground. What is this? Obtain the tangent value, that means angle, tangent value of the angle of elevation of the top of the tower. Top of the tower located at the position F as seen by the child at the position O, whose eye level is 1 meter above the ground. Then you can draw a diagram. Then you can easily get this answer. Now, D. Now, this is a child. Think this is a child, point O, and this is a F point. This is a F point, 60 meter above, 60 meter above the, not above, 60 meter away the O point, F, and this is a tower. This is a tower, right? This is a tower now. This is a tower. The question asks, sorry, 1 meter above the, yeah, this is a child height. It is 1 meter. 1 meter above the, yes. This is 1 meter. Now question asks, what is this angle? What is this theta? Read this question again. Obtain the tangent value of angle of elevation, increasing angle of the angle of elevation to the top of the tower located at the position F as seen by a child at a position O. Over in a child, right? Child at point O, whose eye level 1 meter above the ground. 1 meter above the ground. Yeah, this is a 1 meter. 1 meter. Now this is a O point, this is a F, and this is the tower now. O to F 60 meter, you already know. Can you send the value? I'll give you 2 minutes. Okay, what is the theta value? Okay, you can use tan, right? You can use tan. Okay, what is this height? Vihanger. What is this height now? Now 1 meter above, right? This point to eye level 1 meter. Now it is 14 meter. Good. 14 meter. Now my question, what is the O point to this O point to this point? What is the length? It's not 60 meters. The question asks the top of the tower. Top of the tower, right? Top of the tower. You met. What is this length? Horizontal length? 61 meter, yes. 61 meter because radius 61 meter. Yeah, 61 meter. Great. Now you can use tan. Tan theta equal 14 over 61. 14 over 61. Now, tan theta equal, no, theta equal tan inverse 14 over 61. 14 over 61. You can use calculator to calculate and to get the tan inverse value. Theta equal tan inverse 14 over 61. It is 12.92 degrees, approximately 13 degrees. 13 degrees, no problem. 12.92, approximately 13 degrees. 13 degrees. Approximately. Okay, methodically what that one also enough. The question asks tangent value. The mark scheme accept this answer as well. This answer as well. Right? Okay. That's the end of 2018 essay question, maths question. Okay. Like this, let's complete all area, volume, and coordinate geometry. Let's discuss all questions one by one every Saturday. Okay. Any doubt of this question? No. Then let's start tomorrow 8:30 because tomorrow lesson is very long lesson because tomorrow we have latent heat, specific latent heat, thermal curves, and mixture method. 4 topics. Okay, let's start 8:30 to continue 3 hours tomorrow. Okay, that's all for today. Let's meet tomorrow morning. Okay, goodbye, good night.